Good morning student. Today is going on online physics class. I am Pratish Kumar Acharya. I will discuss about electric field intensity at a point due to an electric dipole at an axial line or broadside on position. Already I have covered first long question, that is electric field intensity at a point due to an electric dipole along axial line or end on position. In that topic I have covered also we have to calculate magnitude of electric field intensity as well as its direction. The same thing is happens on that class in that long question. Okay, here we consider a dipole, that is BC is a dipole. It consists of two equal and opposite charges and they are separated by distance 12. That is, here the point B we consider minus q charge and point C here we consider plus q charge. Due to dipole we have to calculate electric field intensity at an equatorial line. So this is the equatorial point. Why it is equatorial point? That is a vertical line. That vertical line perpendicular to the dipole that behaves as an equatorial line. Here at a particular point A, we calculate electric field intensity. That point A, which is situated at a distance r from the center of dipole O. Clear? Now we assume a test charge plus q naught, which is placed at point A, and also the distance between OB is L. Similarly, the distance between OC is also L. Now I have to find out electric field intensity at point A due to an electric dipole. Let's start. The force experienced by the test charge Q naught due to minus Q charge, that force is attractive in nature and moving in the direction of AB. That's why the electric field intensity is also moving along the direction of force. So that can be represented as a E1 vector. Clear? Because both of are opposite in nature. But this one is the test charge, this one is the source charge. Clear? Similarly, a test charge which is placed at point A, that also create a repulsive force due to plus Q charge. That's why it moves away from CA along in that way. So that the electric field intensity is also moving in the direction of force. So that contain two electric field intensities. That point A contain two electric field intensity. That two electric field intensity E1 and E2 represent what? Two components. E1 create two components and E2 creates two components. Sorry, this one is E2 creates two components. Now the resultant electric field intensity creates two components along horizontal direction, that can represent as a E1 cos theta, that is along XA. Similarly, the resultant electric field intensity creates a vertical component that it can be represented as E1 sin theta. Clear? Similarly, the resultant electric field intensity E2 creates two components along horizontal direction as well as along vertical direction. Okay, so along horizontal direction it can be represented as a E2 cos theta, that can be represented as a double arrow. Clear? Similarly, along vertical component it also creates E2 sin theta. Clear? Now both of the resultant components create an angle to the horizontal axis, that is theta. Okay, if you represent the horizontal axis parallel to the what? Dipole. That's why that angle is theta. So that angle is also theta because two lines are parallel to each other. Oppositely, that angle is also theta. So that angle is also theta because which type of angle? You have to mention it. Clear? So from above consideration, we have to calculate resultant electric field intensity due to an electric dipole at an equitorial line. Let's start theory. So this is the main diagram. Okay, that is theta or theta 1. Here we write and x, y, y. Let us consider an electric dipole BC having charges minus q and plus q. Clear? And distance between them is 12. Let a point q naught, let a point A which is at a distance r from the center of dipole O along equatorial line. Clear? So this is the equatorial line. Now a tester plus q naught is placed at point A so that we have to calculate electric field intensity at point A due to an electric dipole. Okay. Derivation. So the force exerted on test charge q naught due to minus q charge is given by, according to Coulomb's law, f vector f1 vector magnitude equal to 1 by 4 pi epsilon naught q naught by r square. R square means what? ab square. This is the distance between plus q test charge and minus q charge, so that is ab. It is ab square. Okay, square. Therefore, electric field intensity its electric field intensity E1 is given by E1 vector of magnitude equal to F1 vector divided by Q naught divided by Q naught. So here you write 1 by 4 pi epsilon naught Q naught by AB square into 1 by Q naught. That means Q naught divided by Q naught. Q naught cancel out. So E1 vector equal to 1 by 4 pi epsilon naught Q divided by AB means, here AB means, so this one is the right angle triangle. So here in that right angle triangle, this is the base and this is the height, and this is known as hypotenuse. So here we write L square plus R square, so square root. Okay, what? L square plus R square, or square root. So AB equal to what? L square plus R square, or square root. So E1 vector rho mod equal to 1 by 4 pi epsilon naught Q by L square plus R square. Equation number 1. Similarly, force on test charge Q naught due to plus Q charge is given by F2 vector of mod equal to, according to Coulomb's law, it can be represented as 1 by 4 pi epsilon naught Q naught by R square. R square means what? R square means AC. S0 square. S0 whole square. But in that thing, in along E1 vector acting along which direction? AB direction. Means the direction of electric field intensity along AB direction. But in this case, F2 1 by 4 pi epsilon 0 Q naught by AC square, where the direction of force is along AC direction. So that implies electric field intensity E2 vector is given by E2 vector mod equal to F1 vector mod by Q naught. F2 vector mod divided by Q naught. That implies 1 by 4 pi epsilon naught Q naught by Q naught by AC means kona what? AC means that is also L, that is R. So according to Pythagoras theorem, so it can be represented as a L square plus R square. Same thing is represented. So here we write L square plus R square rho whole root over rho whole square. Okay, so divided by Q naught. So Q naught cancel out. So 1 by 4 pi epsilon naught Q by, so square and root both are cancel out. So here we write L square plus R square. Clear? So that is E2. So electric field intensity E2 along the direction AC. So that is along AB direction, and that is along CA direction. This one is CA direction. By mistakenly I have told that is CA direction. So E2 vector along in the direction of CA direction, but E1 vector which is along in the direction of AB direction. Clear? So here electric field E1 vector creates two components along horizontal direction that is E1 cos theta and along vertical direction that is E1 sin theta. Horizontal direction means along x-axis. E1 cos theta along x-axis, and it is E1 sin theta along y-axis. Okay. Similarly, the electric field intensity E2 vector resolved into two components along horizontal direction, that is along x-axis, is given by E2 cos theta and vertical direction that is along y prime direction is given by E2 sin theta. Here that is electric field intensity E1, resolved into two components, E1 cos theta along horizontal direction that can be represented along AX direction. Similarly along vertical direction, that is E1 sin theta along AY direction. Same thing happens along E2 resultant electric field intensity. Now it become resolved in two components along x-axis or x prime axis. So E2 cos theta is here, and along y prime axis it can be represented as E2 sin theta is here. So both vertical components like as E2 sin theta and E1 sin theta are equal in magnitude but opposite direction. Okay, because E1 sin theta and E2 sin theta are equal magnitudes, and also opposite direction, so they cancel out each other. Here we write both the components, both the vertical components E1 sin theta and E2 sin theta are equal in magnitude but opposite direction. Opposite direction, so they cancel out each other. Okay, therefore net electric field, which is acting along horizontal direction, that is along x or x prime axis. Clear? Now, so electric field intensity, which is net electric field intensity E1 E vector, okay, which is equal to, here both components E1 cos theta and E2 cos theta are in same direction, so their magnitude becomes E1 cos theta E2 vector cos theta. Clear? So E1 means what? That means E1 and E2 both are equal quantity, so here we write E1 cos theta plus E1 cos theta, because E1 and E2 are in same direction, so you have to represent in a single electric field. So that's why 2E1 vector mod cos theta. So 2 into 1 by 4 pi epsilon naught q by what, r square plus l square into cos theta. Here in above diagram, so that angle is theta. Now if represent in Pythagoras theorem, so that theta can be represented as in cos theta. So we know cos theta equal to b by h, that is base by hypotenuse, so it can be represented as, so लिख दी परिभाटी cos theta equal to b by h. So here we write b means what, l divided by square root of l square plus r square. Clear? That is the assumption. So cos theta can be represented as, so 2 into 1 by 4 pi epsilon naught q by r square plus l square. Cos theta means what, l by l square plus r square, because here you write cos theta equal to b by h, so b means l divided by this square, that is square root of l square plus r square. Okay, that is the representation. That means 2 into 1 by 4 pi epsilon 0, q is here, l is here, divided by l square plus r square, l square r square, so whole power. This one is root means half and this one is 1, so 1 plus half. So here we write 1 by 4 pi epsilon 0 2ql means what, p. That means I am say p vector equal to 2ql vector here. So 2ql means p divided by l square plus r square power 3 by 2. Here we write. So that is the net electric field intensity. Electric field intensity along horizontal axis. Okay. Now case, if the length of dipole is very small as compared to what? R, so the square of length of dipole, that means L square, which is much less than that of R square. That's why L square can be neglected. Then the equation becomes, which type of equation? This one is the equation. This one, equation number 3 becomes, okay. So this equation becomes E vector, which is equal to 1 by 4 pi epsilon 0 P divided by here R square plus L square, power 3 by 2 is here, so L square is taken as 0. Let's L square tends to 0, so E vector to more equal to 1 by 4 pi epsilon naught P by R square power 3 by 2. That means E vector more equal to 1 by 4 pi epsilon naught P by RQ. So this is the magnitude of electric field intensity due to an electric dipole at an equatorial line or an broadside on position. Now we have to calculate its direction. We know in vector form it can be represented as E1 vector equal to more equal to E1 vector equal to 1 by 4 pi epsilon naught P vector by RQ. Here in above diagram, the direction of dipole moment along minus q to plus q, but the direction of electric field intensity here opposite to that of dipole moment. Dipole moment moving in that direction BC, but the direction of electric field intensity along AX. So both are in opposite direction. Thus, electric field intensity, whose direction opposite to that electric dipole moment in equatorial line. Equatorial line. So that is all about electric field intensity at points due to an electric dipole along equatorial line or broadside on position. We have to compare both two long question, that is electric field along axial line or electric field along equatorial line, so that electric field along axial line is equal to twice of electric field along equatorial line. Why? Because you know in the before class I have told about electric field intensity along axial line can be represented 1 by 4 pi epsilon 0 2p by rq. In that case 2p by rq is here, but in that case in equatorial line electric field intensity can be represented as 1 by 4 pi epsilon 0 p by rq. So here 2 is common, therefore electric field along axial line, which is equal twice of electric field intensity due to equatorial line. So this is the required expression if you compare both the long question, like as electric field along axial line, which is equal to twice of electric field due to equatorial line. Thank you.